Hey guys, welcome to another chicken math video. Today we're going over an FRQ practice, type 4 this time.
Okay guys, this is a brief overview of FRQ4. It's about symbolic manipulations and it will be covering units 2 and 3. Also, it's non-calculator just like FRQ3. Here you'll be given 3 parts. You're going to need to be able to solve equations using functions, rewrite expressions in equivalent forms, find the exact values of expressions. Make sure you can do this without a calculator. Also, know your basic rules such as exponent rules, trig rules, and algebraic rules, and show your work always so that you can get full points.
All right, so this is the example we're going to be going over today. You guys can pause and try solving it on your own, or pause and just look over it and make sure everything makes sense. So for FRQ type 4 questions, a lot of times you're going to be needing these concepts and applying them. So unit circle values, trigonomic identities, and inverse trig functions, exponent rules, log rules, and then the relations between log, e, and ln, and then just your basic algebraic skills. And regarding these directions up here, you want to pay attention to them. So some of these were already mentioned on the last basic information slide, but just keep in mind that the domain of a function f is to be assumed to be a set of all real numbers, and f of x is also a real number. So just keep that in mind that we're working with all real numbers. All angles, we're working with radians, and then everything else was pretty much mentioned on the other slides. So just keep these in mind. These rules will be the same for all type 4 FRQs. Okay, guys, so we're going to start with part A1. We have 2 functions right here. We need to solve for x if g of x equals 10. So first you want to write out what you already know. So that's going to be g of x equals 10, which is going to be equal to e to the x plus 3. So what you want to do is you want to ln both sides, and we'll explain why that is in a second, to get rid of this e right here. If you recall your ln, your e, and your log relations, if you write out ln e to the x plus 3, ln is just log base e. So you're going to get log base e. So you can bring this x plus 3 outwards, because if you're multiplying something by log, that just becomes the exponent of whatever is here. So if you bring your x plus 3 outwards, just remembering our log rules, we're getting log base e to the e. And log base e to the e is essentially saying e, our base, to the power of what is equal to e? Well, this is just going to be 1, right? So log base e to the e is going to be 1. So you're left with x plus 3 times 1, which is just going to be x plus 3. So if you apply that here, ln of e to the x plus 3 is just going to be x plus 3. Effectively gets rid of the ln e. And again, we're looking for x. So you want to find x alone. You just subtract 3 on both sides. And that is x for g of x equals 10. And you don't want to box your answers, because graders might ignore your work. You want all of your work as part of your answer, so you can get those partial points if you need it. So these are our log relations that I wrote down on the whiteboard that you have to recall. And technically on the rubric, this is not needed. This information is not needed. To get full credit, this is what you need, this work. But they're not going to dock points for writing extra on the side. But the minimum is this. You want to make sure you have all your work for credit.
All right, so now we're going to solve for part 2 of question A, which is solving for h of x equals pi over 4 for the values of x in the domain of h. Okay, so we know that h of x is equal to pi over 4, and we also know that h of x is equal to arcsine of x over 2. From this, we can make this equal to sine inverse of x over 2. So we can use our inverse trig properties now as functions, where we know that sine theta is equal to x, and that sine inverse of x is equal to theta. So from this, we can basically plug this into this side, and we see that the sine inverse here is x over 2 and the theta is the pi over 4. So we can do x over 2 is equal to sine of pi over 4. Basically, we just use the property on the left and we plug it in with these values on the right. So now that we know that, we just multiply 2 over and we just solve for x. So sine of pi over 4. Sine of pi over 4 is just root 2 over 2. So it's just x equals 2 times root 2 over 2, or root 2. So x equals root 2. Okay, so these are the answers, full solutions for that question. And we can see on the left, this is the property that I was talking about. We can see it plugged in on that second line in the solution on the right. And from there, it's just simplification and just finding the answer where we get x equals square root of 2.
All right, guys, moving on to part B1, we're asked to rewrite g of x as a single logarithm base 10 without any negative exponents. Okay, so something that's important to note is that all of these logs have the same base, which is 10. So this tells us that we can use different log properties, which will help us solve this. So our first log property is that when we add two logs of the same base, so say I was adding these two, I can just multiply the insides. So that would just look like this. And that's equal to log of 16x to the 7th. Another log property to note is that you can bring an exponent out, which means that you can bring the outside back to an exponent. And I know that sounds really confusing, but that just means that 9 log base 10 of x is the same thing as saying log base 10 of x to the 9th. So the next log property to keep in mind is that when you subtract two logs with the same base, you just divide the insides. So using j of x here, since we already simplified this first part and got log base 10 of 16x squared, we are subtracting that by log base 10 of x to the 9th, which looks something like this. And we can simplify this further using the log property of when you subtract two things, you just divide the inside. So that's just log base 10 of 16x to the 7th over x to the 9th. Now we can further simplify this and we will just get log base 10 of 16 over x squared. And we have to keep in mind the domain restrictions. So x has to be greater than 0 because, first of all, if we put a 0 here, this would be undefined. And then it has to be a positive number because we can't take the log of a negative value. That would be undefined as well. So this is our final answer. So j of x is equal to log base 10 of 16 over x squared. Also, you do not have to include the domain restrictions to get this point as they are not scored, but it may be helpful just to include it so that you can understand what's going on. These are all the log properties that I use, and it's important that you have these memorized as they will be tested in the MCQ as well. And this is the work written out, and you'll get full points if you write it just like this. And it's essentially what I did on the whiteboard, but it's more organized.
All right, guys, so now we're moving on to part B2, and part B2 says we want to rewrite k of x as a single term involving tangent x, and we're given k of x right here. So we're seeing a lot of trig parts, so this is when knowing your trig identities and applying them is really important because we want to manipulate this function into having just tangent x. So first we want to rewrite k of x, so we can say k of x, and then this is important for our work, just rewriting what k of x is equal to. We got 1 minus sine squared x over sine x, and then we got secant x. some of the trig identities that we can notice automatically are the 1 minus sine squared x, and then we have the secant x. So if you recall, 1 minus sine squared x is actually equivalent to cosine squared x. All right, and then secant squared x is going to be the reciprocal of cosine. So secant x is 1 over cosine x. Now for these, you just kind of identify your trig identities, and then you can kind of play around with them, plug things in, and see how things work. Keep in mind we want tangent x. So what is tangent x? Well, tangent is going to be sine over cosine. So we can go ahead and note that down. Sine x over cosine x. So just keep that in mind. All right, so let's replace the 1 minus sine squared x with our cosine squared. So we got cosine squared x over, this is still sine x, we're just going to carry it down. And then we're multiplying that by 1 over cosine x. All right, so let's write this out a little bit differently. We're going to multiply. So cosine squared x is essentially just cosine x times cosine x. And you don't have to write this part down, but I like to, just to make it a little more clear. All right. So cosine x, one cosine x up here and another cosine x up here, they're actually going to cancel out. So you're getting cosine x equals sine x. Or cosine x over sine x, my bad. All right. Now, if we recall our trig identities, tangent x is sine over cosine. But right here we have cosine over sine. So the reciprocal of tangent x is going to be cotangent x. So what we have here is the reciprocal of tangent x, all right? So you can note that cotangent is going to be the reciprocal of tangent. Again, this is just for pointers. Cosine x over sine x. And that's what we have right here. So this is going to be cotangent x. All right. But we need our k of x term to involve tangent, but right here we have cotangent. Well, cotangent is just the reciprocal of tangent. 1 over tangent x. So if we just made this the reciprocal of tangent, just get 1 over tangent x, just k of x. So now k of x is a singular term. There's only one term, and it involves tangent x, nothing else. And that's how you do B2. And one last thing to mention is that sine x and cosine x cannot equal 0 because this is k of x, and this is also k of x. So everything that we're writing equal next to it because this is all equivalent to k of x, right? And we can't have this as an undefined term. So if sine x or cosine x at any point is 0, then that would make k of x undefined. So we want to specify that sine x cannot equal 0. And then cosine x can also not equal 0. That will be part of your answer. So just make sure you mention that. So this is basically what was written on the whiteboard. What is condensed right here in this box is what's needed for your answer. You need to show these steps, and you obviously have to write out your answer with sine x doesn't equal 0 and cosine x doesn't equal 0. You want to make sure you're writing equal signs all the way through so we all know that this equals to k of x. And then the start information is just extra information that I use so you can see what we're doing here. This is not put as necessary on the grading scale.
All right, moving on to part C, we're given the function m of x, which is equal to arc cosine of tan of 2x. And we're just asked to find the values in the domain where the output yields a value of 0. All right, guys, so first we're going to set arc cosine of tan of 2x equal to 0. So we need to recall our inverse rules for this, and let's figure out when arc cosine of x itself is equal to 0. So if we think back to our inverse rules, this is the same thing as saying when cosine of 0, what is cosine of 0 equal to? And from the unit circle, we should know that cosine of 0 is just equal to 1. So this means that arc cosine of 1 is equal to 0. So for that to happen in our original function m of x, that means that tan of 2x must equal 1. So to approach this, we can think about when tan of x is equal to 1. And if we know our trig functions, then we should know that x must be equal to pi over 4. But since this is on the entire domain, we have to add pi k. Also, if you guys are concerned about the domain, the values that wouldn't be in the domain is when tan of 2x doesn't exist. However, all these values are fine. So now to get tan of 2x, we just need to divide all this by 2. So then x would equal pi over 8 plus pi over 2k. And also you must say that k, or where k is an integer value, otherwise you will not get full points. So make sure to specify this. I'm gonna just say int for short, but you should probably write out integer. Also, you can use any variable, like you could say a or b or c or whatever you want. I just pick k because that's what I normally do. So then this should be your final answer. And going back to the PowerPoint, so here's my work that I had put. And I also said that m of x yields an output value of 0 for all input values or x values such that x is equal to pi over 8 plus pi over 2k. I just put this just to be sure and to make sure that I get all points. And if you guys have time, I would definitely recommend doing this as well.
Alright guys, that is the end of the video. Thank you for watching. Please like and subscribe. And we'll see you in the next one.
Bye.
Bye.